Very good. All righty. The name of the program is I Want It Now, and our poster child is Veruca Salt from the original Charlie and the Chocolate Factory, or Willy Wonka and the Chocolate Factory. I think the original was with Gene Wilder. That was the good one. And she wants it now, and that's what people are like, I think, when they're talking about domestic hot water. They want it now in terms of recirculation. We discussed earlier today that there are really, if you think about it, you can categorize consumers, homeowners, end users, and their feelings about domestic hot water recirculation into three categories. I think the bottom category is, I don't care anything about it, just as long as it's inexpensive, I can slap it in, and yeah, I meet code. Really, I just want to meet the bare minimum requirement for domestic hot water recirculation. I want to meet code. Generally speaking, that's your home builder, all right? He doesn't care about efficiency, he doesn't care about performance, he doesn't care about anything else. He just wants it in there, and he wants it in cheap, and after that, it's not his problem. I just want to meet the bare minimum requirements. We have packages for that. The second group, which I think tends to be the larger of all of the three groups, is the group that wants both convenience and economy of operation, meaning they want it to be efficient. They want domestic hot water. They don't want to wait for domestic hot water. They want hot water for the convenience, but they're also cognizant of how much water they're wasting down the drain waiting for hot water. How long does it take to get there? I don't want to wait 5 minutes. I don't want to wait 3 minutes. That's water down the drain. I don't want to waste those resources. And they also know they're paying for that water, and they're also, for the sewage, they're paying to get rid of that water. And they're also putting a lot more work on the water heating unit itself. That costs money to run. And if there's a circulator involved, it costs money to run the circulator. So what they're looking for is some sort of a balance between the convenience and economy, both in terms of saving money, and ecology in terms of not wasting resources. So we have packages for that group too. And then you have the third group, which is the I don't give a darn what it costs, I don't want to wait for hot water. Those are the guys who are on the pump running all the time, damn near all the time. They don't care. The money isn't the problem. I don't wish to wait. Whenever I turn on any faucet in the house at any time of the day, I want hot water, bang, immediately. Okay, we've got ways to satisfy those folks as well. So we've got all these options. And oh, there you go again, Carl. And Carl's a popular guy, and there are ways of dealing with all of those needs. So let us continue. When we talk about, we'll start by laying out some facts and figures about construction, domestic hot water use, etc. Let's start with some facts. Water heating is generally the second or third largest residential energy use behind heating and cooling. You know, in some places it may be ahead of cooling, in some places it may be ahead of heating. It really depends on where you are geographically, and it depends on how much water you use. If you got, you know, that big old honking, you know, 6-person shower stall, so you and 5 of your closest friends can all shower together, well, you're going to have a little bit more of a water heating bill, generally speaking. But it's in that realm. It's anywhere from 14 to 25% of the overall energy pie. So yes, water heating does use energy, but you cannot get away from the inconvenience of having to wait for your domestic hot water as well. There's the economy of it, but then there's just I want to wash my hands, come on, let's go. Or I want to jump in the shower, come on, let's go. I don't want to wait, I'm running late. You know, there's all kinds of life things involved. One of the things we've also been able to learn in our investigations, in our studies, is houses of recent vintage, basically 2005 to today, compared to houses built in the late 60s and early 70s. Everything's bigger. Houses today are simply bigger, and that affects your wait for domestic hot water. Now, back in 1970, the average home was about the average new construction home was about 1,600 square foot. As of 2010, the average new home was about 2,400 square foot. Bigger. Houses were bigger. That's an increase of about 75% just in sheer square footage. It's a bigger house. And with bigger houses come longer runs, to the farthest fixture away. The advent of PVC pipe in the early 70s, PVC and ABS for drain pipe in the early 70s, kind of freed us from that cast iron stack of plumbing. Everything had to be relatively close because it was just crazy difficult and crazy expensive to put bathrooms all over the place because you were running cast iron pipe, maybe with lead and oakum joints or no hub or something like that. PVC drain pipe allowed us to basically spread out construction, build bigger houses, put bathrooms in different places. So it kind of freed designers from the constraints of cast iron stacks. So as a result, the distance from the mechanical room to the fixture that's farthest away jumped about 266%. It was 30 feet back in 1970, 80 feet today. That's a big old honking jump, man. That's a big old honking jump in distance. And then finally, because the houses are bigger, we have more hot water fixtures today than we did in homes built in 1970. Back then, you had maybe 6. On average, about 6 hot water fixtures. Today, it's about double that. Okay, we're up to an average of 12 hot water fixtures, and you can see just by looking at that upper right-hand picture, you got 2 labs and a big old whirlpool tub. Okay, just if you're counting fixture units, you know that certainly does add up. Okay, what does it all mean to us? Well, more fixture units means we have to build a plumbing system that will deliver more volume of water. Okay, more volume of water is very, excuse me, very, very critical. More volume of water means we have to have bigger distribution pipe. The pipe has to be physically bigger to carry that volume. In addition, fixtures of today compared to fixtures of 1970, for resource conservation, they are designed by code to have lower flow rates, both at faucets, at shower fixtures, etc. So bigger pipe plus those lower fixture flow rates essentially means reduced velocity. There's reduced velocity through the pipe. Reduced velocity plus increased distance to those fixtures means, on average, the homes of recent vintage compared to homes built in 1970, it takes on average 18 times longer to get hot water in a home of recent vintage compared to a home from 1970. 18 times longer. Now that really kind of makes you start thinking. That's what Janet Leigh was screaming about in Psycho. Didn't have anything to do with Norman Bates. She got in that shower and it was cold. That's right. I screamed like that when I get the shower was cold. But just by a show of hands, I want to take a quick survey of you guys, and please type in your responses here. In your home, how long does it take you to get hot water to a fixture, to your furthest fixture, be it a kitchen, sink, bathroom, whatever? Just type in, on average, what it does take you. And we're going to get some pretty interesting information out of this. Just type in your numbers here, okay? Okay, we got, Tim says 30 seconds, minute for Sean, 12 seconds for Sean Wiebe. Wow, 7 minutes, 11 seconds, 7 to 11, 30 seconds forever, second floor bathroom. 8 seconds, Vincent, holy smokes. 30 seconds, you guys doing all right. We got 1 minute. Okay, we got so far so good. Not that long. Now, the group this morning, we had one guy 8 minutes. Took him 8 minutes to get hot water to his kitchen sink, which is kind of crazy. Dave Holdorf, 3 minutes, and you got a new house there, man. Brad, about a minute. Okay, not bad, not bad. I'm wondering if some of you guys were 8 seconds. Maybe you do have domestic hot water recirculation in your stack in the deck, but that's interesting information. But whether it's a minute, 2 minutes, 3 minutes. For every minute you run that fixture waiting for hot water, a certain amount of water goes down the drain, generally about 3.5 gallons a minute or thereabouts, depending upon what the distance is, etc. Okay, again, Steve McClinchy, small house, sure. You have a small house in 1970, not going to be that long. A new recent vintage house, going to take a lot longer. Okay, and while you're waiting, you are wasting water down the drain and energy at the hot water tank to make up for what you're running down the drain. Dollars and cents wise, this is from the DOE. Natural gas, electricity, it doesn't matter in terms of usage, it matters in terms of cost. DOE estimates average family of 4, assuming 175 feet of half-inch copper pipe for hot water supply length, blah, blah, blah. We're looking at about $275 for water heating with natural gas, $700 with electricity, and this is assuming a 90-degree temperature rise of your water. So, and a lot of assumptions here by DOE, but this is kind of some numbers that they're shooting at us. Now, how much of that number is actually associated with waste, with weighting and wasting. How much of it is associated with waste? Now we look at the hot water portion of maybe your annual water bill. Water and sewer would be about $110 on average, and this is DOE numbers. Natural gas, $275, electric, $700. The red numbers are the portion associated with waste. Of the water and sewer for hot water only, you're looking at about $36 of your 110. Roughly 1/3 of the money you spend to make and use domestic hot water goes literally down the drain. Okay, natural gas, $275, $92 is associated with weighting and wasting, and electricity it's much higher, $232. Now, heating with natural gas, your total cost for water, sewer, fuel is $385. The total amount of that it goes towards waste is $128. That's roughly 1/3 of the cost. 1/3 of the cost associated with your hot water creation goes towards weighting and wasting. It's useless. It's gone. Now, if we save $128, is that worth it? It's nice. So it may not. It's the money is part of the equation. The bigger part of the equation is that convenience. Okay. Do these numbers make sense to you? These numbers you can work with. And this is kind of broad assumptions made by the Department of Energy with how much of this, how much we spend versus how much actually goes down, literally goes down the drain. Okay, so just give me some feedback if that makes sense. Okay. Hello, Carl. There you go. Now the weighting, of course, is the hardest part. This is a normal person home. The numbers we showed you were for normal people home. You start to get into bigger and bigger and bigger shacks. The waste in terms of water, the waste in terms of money, obviously becomes that much greater. Now, we said this I think a little bit earlier. The Department of Energy estimates a normal family of 4 will waste up to 12 to 14,000 gallons of water just simply waiting for hot water. Just simply waiting. Over the course of a year, they will lose 12 to 14,000 gallons of water right down the drain. Now that's a precious resource that we're wasting. It's also money that's going down the drain. Okay, so the money part, the waste part, the fuel part, that's all important. But then for some people, it's just a matter of inconvenience. There's the waiting. Okay, and as Tom Petty said, the waiting is, of course, the hardest part. So we're going to look at some solutions for recirculation. But a point I'd like to make to you is as we look at these different solutions, you will find customers that are concerned about, they're concerned about the weight, but they're also concerned about the cost. Now, of all of the solutions, ours and the competitors combined, there are ways to do domestic hot water recirculation where the actual cost of electricity to run the pump combined with the cost of additional fuel at the water heater actually outweighs the cost of just letting the faucet run till you get hot water. In terms of overall cost, that $128 we were talking about, there are ways to do domestic hot water where it's either a wash in terms of dollars and cents, or your recirculation actually costs more. Your recirculation actually costs more than waiting and wasting. Some people, again, don't care. Some people just couldn't care less about waiting and wasting. They just want hot water when they want it now. You have other people who are into, yes, I want hot water, but I also want to conserve energy and lower my bills a little bit. Then you've got to look at different solutions. Now, we have solutions that cost more. We have solutions that would be a push or pretty much a push. And we have a very unique solution that is actually the only solution that actually costs less. Okay? The electricity and what you use at the water heater actually costs less than the cost of running the pump and what you'll spend back at the water heater. So those are some different ways we're going to look at this and the way we're going to approach this as we move on. But it's an important thing to keep in mind, because just because you have domestic hot water recirculation doesn't mean you're going to automatically save money. It has to be well thought out. It has to be intelligent. And that's a great training approach we can bring to our customers. When you're presenting to your customers, that's a very interesting approach to take, because that's going to appeal to different levels of their customers. So let's start with your simple recirculation solution. What we're going to do here is we're going to go through all of the TACO offerings the complete Taco line, and then we're going to go look at each individual product. Okay, I'm sorry. Then we're going to take a look at the individual competitors and see where they stack up against what we have in pros, cons, head-to-head, tail-to-tape kind of thing. All righty. Now, we'll start with your basic plumb and plug. We've had this thing around forever. It's a neat, simple little package with a line cord. The timer is right on the butt end of the circulator, so it doesn't take up much space. It's nice and neat and sleek looking. The standard plumb and plug, of course, is timer controlled, so you set it to when you want to run and when you don't want it to run. We have the analog timer, which is standard 24-hour. It's a 24-hour timer, and it's broken down into 15-minute increments. If you see all those little white peggy things there, little dippy switchy things, those are 15. Each one of those represents 15 minutes. So you move the dip switch to one position when you want it to run. Maybe you want it to run for an hour in the morning. So you move all the dip switches for that hour in the morning, and that means you'll have hot water there ready when you need it. And then you leave the other ones off. Okay, and the thing is, it's going to run on that pattern every day. Same pattern every day. The digital timer is a bit of an upgrade, but it gives you the ability to program out 7 days, 8 events. That says 10. It's really 8 events every day. So you have 7 days, 8 separate events each day for a total really of 56 events if you look at it that way. So we have those capabilities. So the digital timer gives you a little bit more flexibility to program day by day. With the analog, same thing every day. Okay. Also, that is also optional for this particular product, which is, I think it's a very important piece of equipment for added efficiency. The basics plumb and plug is your bare minimum. Put it in. I've covered my minimum requirement, and I'm going to walk away. That's your builder special. Okay. To make it better, more efficient, more effective, you can include an optional aquastat for the pump. And this is a strap-on aquastat that goes on the return leg of your hot water of your recirc line. And basically, it's kind of a high limit. It acts as a high-low limit, a high and low limit while the pump is operating. If you're recirculating and the water temperature exceeds 115, the dip switch will tell this thing to turn off. Okay. If you're recirculating and the water gets below, if you're in that recirculation, or if you're within a mode you get below 95, it'll tell it to turn on. So it'll bop back and forth in between those two. So off at 115, on at 95. So it's not constantly running. Okay, we have that timer and temperature feedback for maximum efficiency for that particular pump. So it's not, say you have it set to run for a full hour, it doesn't have to run for that full hour. It'll only run as needed during that full hour based on time and temp with that high-low limit aquastat. It tremendously adds to the overall efficiency of the system, both electrically and at the water heater. And then lastly, we have this particular product, not recommended for tankless type water heaters. More of a as needed type of recirc is beneficial there. The Taco Genie, as we get to it, and the On Command that you know of now would be the ones that fit in with the tankless instantaneous type water heaters, but not the plumb and plug, so to speak, because they're based on time, not usage. And you want your recirc for a tankless type to be based on actual need at the moment, actual use of hot water. And the recircs, the plumb and plugs, are available in the 003, 008, and 006 models. Carl, anything you'd like to add there for plumb and plug? Oh, Carl. We must have lost Carl. Okay. Vincent asks, are the aquastats limited? Aquastat limits fixed at 95, 110. Yes, they are. They are fixed at 110. Okay. Or I'm sorry, at 95 and 115. That's a fixed temperature. Okay. Next in the whole house kind of recirc line is our friend the Smart Plus, and this is wicked smart. This thing is it kind of sets the standard for intelligent domestic hot water recirculation. You'll note there's no timer here. We don't worry about time or temperature here. We're concerned about actual usage. So because of that, it's not just Smart Plus. As they say back in Rhode Island, it's wicked smat. It's not just smat, people. It's wicked smat. That's a smat pump right there. And it's got some serious intelligence bred into it. What the Smart Plus does is it learns. It learns and adapts to the changing needs of the homeowner. It learns and adapts to their hot water usage patterns. And not only does it learn, it continues to learn. It's constantly seeking information, constantly seeking knowledge. So it's like hungry for information. And it will run as needed based on your usage patterns, okay? There's no programming involved. The hardest thing you have to do here is put the switch into, there's really nothing, because the switch, it comes out of the box programmed to the learning mode. So really, in that case, there's nothing you have to do in terms of programming. The hardest thing you'll have to do is install it and plug it in, basically. So there's no programming involved. Now, how does it work? What does it know? What makes it so smart? Let's take a gander here. Here's your piping options. It can be mounted on either the supply or the return on your return hot water leg. It doesn't really matter either or. The thing that does matter is the location of the sensor. You do have to wire up an external strap-on sensor, and that has to be installed on the supply side, okay, on the gazouta side of the water heater with your hot, where the water is the hottest, but a minimum of 18 inches away from the water heater itself. I mean, a little bit further is probably better, so it doesn't get falsified, so it doesn't pick up any of that gravity feed of hot water. So you want it so it's going to sense an event. And what this thing does is it sets events. So you install either on the return line or on the supply line as shown. That sensor goes on the domestic hot water outlet at least 18 inches away from the water heater. More is better, of course, but still within the mechanical run. Now the pump is set to smart mode coming right out of the box. It's set to smart mode. What it does when it's in the smart mode, as you see right here, is it does for the first 7 days, even though it's in smart mode, for the first 7 days it's going to pulse, meaning it'll run 2.5 minutes and then it'll be off 10 minutes. Run 2.5, off 10. Run 2.5, off 10. So it'll continue that mode for the entire week. So chances are you're going to have hot water when you want it needed in the pulse mode. Immediately you'll notice that difference. But what it's going to do while it's in that pulse mode is it's going to record events as measured by the sensor. And an event with the Smart Plus is measured as a temperature rise, sustained use, and then a drop. So temperature rise, sustained use, and a drop. In most cases, that's a shower, okay? Where the water temperature increases, you have a sustained use, and then it goes down. So the brain is going to measure, going to record those events, and then keep note of them all throughout the week. So it's going to record your usage patterns for the first 7 days. After that, it's going to repeat the pattern for the next 7 days, while again learning any changes or adaptations. So it's going to constantly record, learn, adapt, record, learn, adapt, and record, learn, and adapt. So it only runs when historically you use hot water. So you don't have that instance where, you know, I gotta program it for this part of the morning and it's going to run for all that time, and then boy, I want it a little bit in the afternoon, a little bit here, and it's going to run like that whether you need hot water or not. This is only going to work based on your recorded patterns. So here's an example. Say you install this thing on a Sunday, and first thing Monday morning, get up and take a shower. And it's 6:30 in the morning, and you take a nice long shower, and that's great. So it's going to record that. It's going to remember that event, and then next Monday, the pump's going to start pulsing. It's not running continuously. It's pulsing. 2.5 minutes on, 10 off. 2.5 on, 10 off. It's going to pulse starting at 5:30, and it's going to stop pulsing and go completely dead at 7:30. Okay? So 2.5 minutes on, 10 minutes off. 2.5 minutes on, 10 minutes off for that 2-hour period. For that around that 6:30 shower. All right, and then it's going to continue to remember those hot water uses. All right, and then basically what you do here is it just wash, rinses, and repeats. It just keeps it going. Wash, rinse, repeat all throughout the week. Okay, so that's basically how does this thing work. A couple of quick questions. Are we going to come up with something for tankless with a plumb and plug 0011? Asked Bernardo Vizcarra. Carl, are you with us?
Yes, I am.
Answer that question. A plumb and plug 0011, let's say, for tankless. Yeah, I'm not sure the plumb and plug is the right solution for a tankless.
You're right, John. A timer pump, you typically have to run the pump at least 15 minutes. And with a tankless, you wouldn't want to have long run times You just want to move the water from point A to point B quickly when there's a flare. So, and a Takeo Genie is a much better solution for that type of application.
Yeah, anything with a timer just simply does not make sense with a tankless. And Carl, you probably might know this better than me. The manufacturer's requirements or guidelines for hot water recirc with their products.
Some of them will recommend the use of an on-demand type, similar to the Takeo type of. Some even will extend their warranty on their product, but they do not recommend the use of timer-type pumps.
Okay, very good, very good. Bernardo, I'm going to get to your second question in about a minute here. Jameis Burke asked, does it matter if the sensor is installed before the TMV or after? I think you want it, with the thermostatic mixing valve, I think, Jameis, you want it installed on the tempered water side. Okay, again, on a mixing valve, you want it after, you want it on the mixed hot water side, not the water temperature coming out of the tank. You want it on the water temperature that's going out to the plumbing system. That would make the most sense. So I think that's where you would definitely want that to go. Okay. Smart Plus on instantaneous. Again, same thing. I don't think that's going to be the right solution. Again, you don't necessarily want long run times with your domestic hot water recirculation pump with a tankless either. You want it to be on, get the water to the hot water fixture, and then shut off immediately. So I don't think, Eric, that a Smart Plus is really the best choice with a tankless as well. Would that be correct, Carl?
Yes, we have had some requests to use the Smart Plus, and we have done some testing. There would need to be some modifications to the programming on the pump relating to the run times. So at this time, that wouldn't be a good alternative.
Yeah.
Today, the Takeo Genie would be your best choice for tankless.
Yeah, and as you'll see, we really do have the best solution for tankless, and really the only practicable one, as we will see. Okay, a question came up from Eric about the vacation mode. Smart Plus has a vacation mode. No usage, no events for 36 hours. Well, that kind of says, hey, the pump says, hey, ain't nobody here, right? Nobody here but us chickens, right? There's nobody home. Nobody's using hot water. It's been 36 hours. I'm going into vacation mode, pal. I don't have to run. There's nobody's here. Why bother? So it shuts off until the next event. Okay, so when you get back, you have the next time there's an event, it goes, okay, I'm back. I'm awake. Back to work. Okay, it'll go back into its programming. What it will do in vacation mode is it will exercise the pump for 10 seconds every 7 days. Okay, just to keep the water from getting stagnant, keep the pump up, keep the pump in good shape. So again, there's your vacation mode. It's a 36-hour time frame, and it essentially shuts off until somebody comes back and uses some hot water. Okay. Very good, very good. Now let's move on. You notice that switch had smart and then it had pulse. The optional pulse mode is very useful if there's a home with no fixed routine, where maybe you work odd hours, or if someone works from home, like I do, work from home. I don't get up at 6 every morning, shower, and go to work. I get up at 6. I get up at 6 every morning, go to work, and then I'll shower somewhere during the day. I mean, that's just the way it is. And some people have different non-fixed routines, on when they use their domestic hot water. If there is no fixed routine, then the pulse mode is a really good alternative there. That means it just runs 2.5 minutes on, 10 minutes off, 2.5 minutes on, 10 minutes off throughout, forever. Okay, so it'll work in that mode. It'll work like that. And will the vacation mode work on the pulse mode too? I'm going to throw that one at you, Carl. I don't believe so, but does the vacation mode work in the pulse mode?
Yes, it does.
It does? Okay, so if it does not measure an event,
yes,
and you're away, it says, hey, I'm going to do nothing. Okay, very good. I did not know that.
I'm sorry, John. The key to that is that you have to install the temperature sensor. So you have to make sure that is installed in either smart or pulse mode, because if the pump drain is not seeing temperature change, it will go into the temperature mode and stay there. So you want to make sure whether you're in smart mode or pulse mode, you attach the temperature sensor to the hot water supply pipe, and then in either mode, the pump will go into application mode if it does not see hot water usage for 36 hours.
Very good, very good. That's good to know. Good to know. Again, an important installation tip: make sure that all you guys know, no matter what, you have to install the sensor, and that's always. I can see that one being one of those field things.
And could I add one more thing, John? I just thought of.
No, I'm sorry, Carl. You've used up your allotment of points.
Okay, I'll sit here silently.
No, you please go right ahead.
Thank you, sir. If you were to change the mode, if you install the pump and then decide at some point to change the mode, you must unplug the pump, number one, for safety reasons, but you have to unplug it to reset the board. So when you remove the capacitor cover to flip that toggle switch to smart or pulse or vice versa, you have to do that with the electrical cord, the line cord, unplugged from the wall outlet. Once you change it, plug it back in, and it will go into that mode.
Okay, very good. So unplug, change the mode, plug it back in. Very, very good. Okay, Vincent asked about the vacation mode and pulse mode. I think we answered that. I hope that you caught that. Yes, it does work in vacation mode in the pulse mode. Very, very good. Alrighty, now let's talk about the Taco Genie. We've been discussing the tankless stuff. Let's talk about the Taco Genie. And no, not that Genie, not Barbara Eden. And as I told the group this morning, actually this picture came from my, my collection of Barbara Eden memorabilia. I do have one of the largest Barbara Eden memorabilia collections in the upper Midwest, being here in Minnesota. I personally consider it a very thorough and extensive collection. My wife just considers it creepy, but hey, what the heck. No, it's not that Taco Genie, it's that Taco Genie, okay? That Taco Genie. That is your, you might know this as the On Command currently, but Carl, as of December 1st, it will be known as the
Taco Genie.
The Taco Genie, yes, coming your way December 1st. Name change, product is essentially the same, and the part numbers will also be the same, but it will be of a new name. Any other functional differences or accessory differences, Carl, with the Taco Genie?
No, just a fabulous new name.
Just a fabulous new name, and, of course, we will send an autographed picture of Barbara Eden out with everyone. No, we can't, but it would be nice if we could. I have enough here, so it would be, if we could do that. Anyway, the Taco Genie is one of those only runs when you need it kind of pumps. It doesn't work on a timer. Their temperature is involved, but temperature doesn't make it run. Temperature makes it stop. All right. It is a user interface. The user has input on when it runs, and this makes it perfect and uniquely applicable for tankless water heaters. Because tankless water heaters, by design, only run when you need hot water, right? That's why they're also called instantaneous or tankless water heaters. They only run when there is a need to have hot water. Okay? There's no storage involved, and there's no maintaining temperature of water when it's in the tank. There's no tank. So it only runs when the user is using hot water. What the Genie does is it's like consider this a pre-purge kind of pump. It gets the system primed with hot water in advance of a specific instance in which you're going to use hot water. So think of it as a pre-purge for the plumbing system. Okay? It's a high head pump, and it's a high head pump for two reasons, which we'll get to. It can be enabled either with a push button, either a hardwired doorbell type push button that you see down in the lower left-hand corner of that little picture, or with a wireless remote sensor, remote button. It's that black little button-looking thing that you see on the right-hand side. It has an optional receiver that would be wired into the pump as well, that thing right underneath the push button control. Or it can also be enabled with a motion sensor, which once the beam that the motion sensor puts out is broken, it could enable the circulator. But it's very much a system that runs only when there is a need for it to run. We talked earlier about an option that is the least expensive in terms of both electrical consumption and additional consumption at the water heater compared to simply waiting and wasting. Gang, this one is it. Taco Genie is the only option that we have that anyone has in which the cost of electricity and the additional cost of gas or electric use at the water heater is actually less than, considerably less than, the cost of water and energy if you're simply waiting and wasting. Some other instances, the electricity and the fuel cost more than waiting and wasting. Others, it's kind of a push. This is the one that saves the money. Okay, this is the one that saves both money and water. All right, this is the solution because it only runs as needed. Now, it can be mounted underneath the sink, underneath the vanity, at your furthest fixture as a retrofit, or it can be installed at the water heater with a dedicated recirc line, either one. And this, again, is the one you use with tankless types because it's a high head pump, so it can overcome the head loss through the high head heat exchanger of the tankless water heater and trip that flow switch. In addition, it's also the one that will evacuate the hot water lines as fast as possible. So it works quickly and only when you need it, when the consumer commands it to run. Okay. So again, overall, this is the most energy efficient solution. So for your folks that want to go green and want to be not only economic but ecologic as well, we have that solution for them. Here's your under sink installation, all right, with a standard tank type water heater. And what this does is it uses the cold water line as the return, okay? And you see it installed underneath the pump. You see the heat sensor on the inlet side of the pump. There's electronic controls strapped onto the pump. And if you have a wireless activation device, you would need to also install a remote receiver underneath the sink connected to the pump, so it'll work. Now, any one of these devices can turn that pump on. The motion sensor, the motion sensor is wired, as is the button. Both are wired, and the remote activation buttons are wireless. But let's say you get up in the morning. First thing in the morning, you get up in the morning, you're getting ready to take a shower. First thing you do before you take a shower, instead of turning the shower on and letting it run and waiting for the water to get hot, you push the button and then do whatever you would be doing while you were waiting for the water to get hot. Just push the button. By the time you're ready to get in the shower, bang, bang, the water's hot. The reason we use a high head pump here is what the goal of this pump is going to be. It's going to be to evacuate that hot water line of cold or tepid water as quickly as possible. We want to do it within a matter of a few seconds. All right? Press the button, the high head pump comes on, bang! We want to evacuate, bang, it doesn't make noise, but bang, we want to get that cold or tepid water out of the hot water line as fast as possible and get hot water to that bathroom group as fast as possible. Now, you note that heat sensor. It's actually a little well type of sensor that's in the inlet or the Gazinda side of the pump. That is not a fail-safe, but that's a secondary control. The push button or the activation device turns the pump on. What the heat sensor does is it turns the pump off once we sense a 5 to 10 degree temperature rise of the water coming into that pump. At that point, the pump realizes, hey, hot water's here. I don't got to run anymore, so I'm off. All right, so you tell it when to turn on. It turns itself off once it senses an acceptable temperature rise of the fluid. The hot water's there. You turn on your faucet. You take a shower. Ba-bum, ba-bum, you're good to go. Okay? Let me know if that makes sense to you, because that sensor on the Gazinda side is an important element. Okay? So we have a couple of questions here real quickly. Do we have an HSV valve same as demand? It's a supplement for ACT that keeps hot water from passing to the cold water side, also for sprinklers from firing off tankless. HSV, you're going to have to explain that a little bit more, Bernardo. I don't know if that sensor on the Gazinda side answers your question. You'll have to elucidate a little bit on that for me, if you would. And can we design a setup showing which way? Say that again, Carl?
I can answer that.
Please do. Please do.
Yes, what he's talking about is a shutoff on the outlet side of that pump that ensures if you have a high flow faucet, for example, an outdoor spigot that you open, could pull the check valve open in the pump. We use a stronger check valve, but we do not have optional HSV type valve or any type of valve that you could install on the outlet side to prohibit the check from being pulled open.
Oh, good. Gotcha. Excellent.
Yeah.
Very good question, Bernardo. And he comes up with another one. Can we design a setup showing which way to show increase and decrease delta? A picture of this will reduce call. Plumbers like pics. Way to show increase and decrease in delta. Could you explain that one a little bit more too, Bernardo, unless you've got a handle on that. Do you have a handle on that, Carl?
Yes. I think he's talking about the sensitivity setting on the control board.
Okay.
And we don't put instructions out on that because we find, the concern is that a lot of homeowners may go online and attempt to change the sensitivity on their own. So we're concerned about putting that information out there. We don't want people, to access the board, you have to remove the capacitor cover and go into where all the electronics and electrical connections are. And we want to make sure that homeowners aren't in there messing around with things. So we prefer having calls to the factory so that we can ensure that the adjustment is set properly.
Okay, very good. And how many wireless buttons can we use with a pump, Carl?
It's really unlimited. We haven't tested, 10 or 20 controls, transmitter buttons, but certainly you can put multiples in there. It's not an issue. We've had some people do 6, 8, 10 of them.
And then Bernardo asking, are we looking to raise the delta T, meaning at what point are we looking to make it higher before the pump shuts off? Is that your question, Bernardo? If that's what you're asking? I know, Carl, if you can address it. Are we looking to raise the delta T? I mean, I think you're just talking about the increase in temperature on the Gazinda side.
That's right. I think what he's asking is, are we going to make it less sensitive so that you'll move more water and increase that delta T to let the pump run longer before it shuts off? We do not have any plans to do that at this time.
Okay. And then James Burke asks, if the sensor was to fail, what would be the indication? Would the pump not function at all or run all the time? I'm assuming you mean the heat sensor, James. What would be if that sensor were to fail? How would you know?
If you always have to start the pump somehow, either a push button or break the motion sensor. The pump itself has a 4-minute runtime maximum. So if you're used to that, maybe 15 or 30 seconds, and you start to notice that it runs for 3 or 4 minutes before it shuts off every time you activate that button, then you could have an issue with the sensor, or the temperature sensor.
Okay, so again, generally speaking, in most cases, the pump might run 15 to 30 seconds. Again, that's why we have a high head pump. If the sensor were to fail, there is built into the circulator a maximum 4-minute runtime?
That is correct.
Okay, good. Again, good to know.
Whether it fails or no, if it couldn't satisfy temperature, it would only run for 4 minutes.
Okay, very good. And again, it's not going to run all the time because of the 4-minute runtime, and it is always enabled by the sensor itself, by either the motion sensor or the remote activation button. Okay, so it has to be physically turned on in one way or another. Okay. Oh boy, we've got a lot of questions here. Here we go. What about when there's a water softener? Water softener probably doesn't enter into this because water softener is before the water heater. So I don't think a water softener, Peter, if I'm understanding you correctly, water softener is not going to matter one way or the other on this because generally you come out of the water softener and go into the hot water tank. You're in this case, it's not going to make any difference one way or the other.
Yeah, if he's concerned about pressure drop, increased pressure drop to a water softener, it may be a case of using a larger take or genie.
Potentially.
That's his
Okay.
concern.
Okay. All right. If that would certainly make sense. That would certainly make sense. But then that's going to be pressure-wise throughout the entire system.
That's true.
Now here's your piping arrangement if the genie is on the return side, okay, of your piping. If you have a hot water recirc line, a dedicated recirc line coming back from your furthest fixture or furthest fixture group, it doesn't have to be at the sink. It can be in the piping going to your furthest fixture group. You would have to wait a couple of seconds for your hot water, but it's a heck of a lot better than a couple minutes. And you have your return line being piped back to the water heater, and now the circulator and all of the controls, remote receiver, everything, that's back in the mechanical room. Okay, so this is, again, it's pretty much the same thing, only different. We don't use the cold water line as a return. We have a dedicated hot water recirc line. So here's some real basics on sizing. Okay, sizing domestic hot water recirc pumps there's no magic to it, and there's very little math that needs to be done, because all we're trying to do, gang, is get a trickle of hot water at the furthest fixture at a point in time when we need it to. We're not boosting pressure. It's not the thing that delivers the hot water. The street pressure does that. We're not trying to create a certain amount of gallons per minute at the faucet. I mean, none of that plays here. All we want to do is when they turn on the hot water fixture, there's hot water there. That's all we're trying to do, and there's not a lot of math involved. It's just a matter of how long is the run, what size pump should we need. So when we're talking about the Genie, you can do a 6, 8, or 11, a 006, 008, or 0011, and it has to do with the type of the length of the run. Now, standard piping for the Genie means that pump's underneath the sink. All right, that's what we would consider standard piping for the Genie. The pump's underneath the sink. If it's the total length to that sink is no more than 50 feet, a 006 is fine. Medium size of home, total length is 100 feet, 50 to 100 feet, you want to look at a 008. If it's over 100 feet, then you're looking at the 0011. In the recirculation piping system, where you have the pump back at the water heater, then you're looking at the 006 or the 008, just total length of pipe, 100 feet total. I mean, there and back again, 200 feet there and back again max for the medium, for the 008, and anything over 200 feet, use the 0011. Okay, so real simple sizing. There's not a whole lot here to get yourself tripped up on. How many wired motion detectors can you install, Carl?
You can have multiples. So again, we haven't tested the max, but if you wanted to wire in 5 or 6 of them, no problem.
Okay, so yeah, it's as many as you need. Now the thing about the wireless, the motion detectors, that's those will turn on when someone simply walks into the bathroom, regardless of what they're doing. The good news is the pump only runs for 4 minutes maximum, if that. And the sensor will tell it to turn off. But Carl, what about if someone keeps walking in and out of the bathroom for whatever reason? Maybe they're cleaning it or putting towels away or whatever. What happens then?
I'm glad you asked that, John. What will happen is that the motion sensor itself has a lockout of about 6 minutes. So if someone would walk into a bathroom, activate it, and then leave the bathroom, someone walk in right behind them and break the beam, the pump would activate. So it has that 6-minute lockout in it. It would wait the 6 minutes, and then someone would have to pass and break the beam before it would start again.
Okay. So yeah, you'd think you'd use the remote activation, like in a kid's bathroom or a guest bathroom or something like that, where maybe the guest wouldn't know to push a button every time. Master bath, something like that. Well, then you can have the push button, either the wireless or the wired push button type of control. And again, it's a lot of people look at it and say, well, this is just too much of a habit change. I don't want to have my customer push a button to get their hot water. Okay, it's a matter of you push a button or you turn the faucet on and wait. One of the two. Either way, it's something you're going to have to live with. Pushing a button is not that hard once you realize what can happen. But again, if it's one of those customers that says, I don't want to do anything, I don't care how much it costs, I just want domestic hot water, well, we have other options for that. Okay, they're in that upper level of I don't care what it costs, I just want the convenience more than anything else. We have solutions for that type of application. Okay, is there a distance limit between the transmission receiver and the sensor for the wireless for the wired sensor, or for the, I think you mean the remote, the wireless activation button? I think, is that what you mean, James? Is there a distance for the wireless activation button, Carl?
Yes, if you're talking about the transmitter button that you push, you put it in a bedroom or some other room, it's a maximum of about 90 feet.
Okay, so 90 feet between the button and the circulator. Okay, very good, very good. Alrighty, now here we show it piped up with a tankless as a recirc. Okay, tankless with a recirc. Now previously we had tankless under the sink. Here's tankless with a recirc, and again it's very similar. You just have your recirc line coming back from your furthest fixture, and then it simply pipes into the cold water feed line into the tankless water heater as shown. Now again, in both applications, the thing that turns a tankless water heater on is flow, right? Well, this is going to create that flow. It's going to evacuate that hot water line of cold or tepid water instantaneously, as fast as it possibly can, and use that dedicated return line or the cold water return line to go back to the water heater to complete that loop. Once the water's hot at that furthest fixture or at the return sensor line, point in this application, pump's going to shut off. The line's going to be primed and ready to go. All you got to do is turn on the shower and bada bing, you're ready to take a nice hot one. So again, that's the thing. Think about this as priming that hot water line with hot water. Might be the best way to look at it. Okay. Very good, very good. All right, and then sample sizing. If you have the under sink installation with the Genie, all right, a small or medium home, if the total length of pipe to the Genie, to the Gazinda side of the Genie, is less than 60 feet, 008 is your choice. Larger homes where that total length of pipe is greater than 60 feet, you'll want to look at the 0011, again, higher head pump. If it's a recirc line installation, I messed this one up earlier, and thank you for pointing it to me. It's not length of pipe per se, it's square foot of the house. If the total square foot of the house is 2,500 square feet or less, and you have that recirc line, 008 will get it done. Bigger than 2,500 square feet, you're going to look at the 0011. So now it's just a square footage issue. Okay, really no secrets, no tricks, no math involved in sizing these things. It's just based on the run. How long do we have to run? How big is the house? Real simple when it comes to sizing domestic hot water recirc. And the thing is, they don't have to be real big. It's amazing. Other than the Genie, where you want a big, powerful pump that's on demand or on command type of thing, and you want to get that hot water out fast, every other application, Carl said earlier today, time is your friend. We have time to get the hot water. We don't have to force it quickly. Everything else, time is our friend. Here, what's our friend is the high head of the circulator to get it done fast, because it's a point of use thing, and it works with a water heater that makes hot water on demand as well, with the tankless. Okay. All right, how's the pace here, gang? Let me know. Do you have any further questions? Type them in. How's the pace? Are we doing good? Is this useful information? Give me a little feedback in the question thing, and then we'll continue to move on. And Carl, are you enjoying yourself out there?
I'm loving it, man. I could do this all day long.
Yeah, you know what? You probably are going to be doing this all day long. Well, actually, no, today, this is the last one today. We have 2 more on Monday, so very good. So again, how's the pace out there, guys? So far, so good. Excellent. Great. We've got some good positive feedback. Now let's talk about the hot link. The hot link is something that really raises the bar on retrofit domestic hot water recirculation. And the thing that raises the bar is that little black thing on the left-hand side, the hot link undersink valve. It's a crossover valve. This changes everything. The industry standard has long been the Grundfos comfort system with its crossover valve. And when it comes to setting the bar, that crossover valve of Grundfos really sets the bar low, man. It sets the bar really low. This little device here changes everything, because it's a valve that is superior in many ways, and it's a valve whose story needs to be told by you guys to the people to whom you speak. Everything that's weak about the Grundfos valve is strong about this one. If you ask your customers, hey, that crossover valve from Grundfos, how much do you love it? You're probably not going to get a whole lot of enthusiasm. Hey, it meets the need, it meets the code, I put it in, I'm done, I get the hell out of there, I know someone's going to have to replace it within a year. Not so with this one. So let's take a look at the overall package, and you can see some of the differences. Perfect timing. The plug and plug The hot link consists of a plumb and plug circulator, 24-hour circulator, as shown here. Also with all unions and hoses and all the stuff that you're going to need to install it, as well as the hot link bypass valve, as you show here. And again, it uses the cold line as a return line. But again, it doesn't let hot water get into the cold water lines. That's one of the things it's designed to not do. Okay? Here's your setup with the hot link bypass valve. The valve itself has an integral thermal sensor disc. Okay, if you look at the pictures to the left, the disc kind of goes concave and convex a little bit. When we're starting this thing up and we're trying to empty the hot water line of cold or tepid water, that disc will allow the cold or tepid water from the cold hot water line to pass through into the cold water line. As soon as we reach an acceptable temperature, okay, that thermal sensor disc will kind of click closed. So no more hot water goes into the cold water line. It's completely closed off, and all the hot water is directed up to the fixture itself. Okay? So that's kind of how it works in theory and in application. So when the hot water arrives, that thing snaps shut, and we're good to go. And extensive testing has told us is that even if the circulator is programmed to run for another 15 minutes or so after that happens, you know, not really an issue, because such a small pump like the 003 or 006, deadheading like that for such a short period of time, just not a problem. It's just not a problem. It's not anything to really worry all that much about, because it's such a low flow, low head pump. Now underneath, the picture itself tells you everything you need to know about this bypass valve, is that it is actually serviceable in place. You get any crap, crud, or whatever in that valve, it's designed to be serviced without removing the entire valve, and this becomes important when we start to look at the competition's crossover valve. Okay, you just unscrew that plug, clean out the debris, put the plug back in, and you are good to go. You're all fresh, clean, and brand new. All you have to do is shut the water off. Okay, you don't have to disconnect the valve itself or remove the valve itself. It's just you turn off the hot and cold angle stops, take the pressure off the faucet, open it up, let whatever water is in there drip out so there's no pressure. Then with a little bucket underneath, you unscrew that nut. Out comes the whole sensor. You can clean and flush the whole thing right out, and then put it back in. You're good to go. It's a 15-20 minute service call, if that. Okay. It is retrofit ready, as you can see. You have your hot link valve at the fixture. You have your circulator back at the water heater. Install the valve, install the circulator, program, and presto, you are in the domestic hot water recirculation business, which is pretty simple and pretty easy. Now, if you got a larger, more spread out house, people always ask, can I have more than one hot link valve on a system? Oh, heck yeah. Heck yeah. You can do something like this. You can have as many, all the hot link valves that make sense. You can certainly install. Now, Carl, you had mentioned something about the best applications for this kind of approach with multiple valves earlier today.
Yes, if your piping splits, you have a main trunk and then it splits. Maybe typically in a large ranch house, you might have a master bedroom at one end with a bath, and at the other end you have your kitchen or another bathroom, and your piping splits. It would make sense to have a valve at each end. And anything in line of that valve, if you had a kitchen and a bath, anything in line would be picked up by that valve that is installed at the furthest point. So it's not uncommon to have 2 or 3 valves with one pump down at the water heater.
Okay, very good. A couple more questions. Bernardo, you're on fire today, bud. Can we look into a check valve in case of backfeed into the water heater? Is this a concern? Do you get that one, Carl? I'm kind of trying to...
Yes, we have a check valve in the hot link valve itself that prevents water from moving back through from the cold to the hot side.
Okay, so if they were running the hot water, if they were just running the cold, it wouldn't necessarily push cold water into the hot side, whether that little disc was open or not.
That's correct. About a little more than halfway across that valve, there is a one-way check.
Okay, very good. Very good. Good question, Bernardo. And here's another one. I would like to have a 10-foot cord. 6 foot is way too short. Tank heater is 5 foot tall. I'd rather have someone zip it cord and then add an extension cord. Not sure about UL listing. Comfort Series has a 10-foot cord. We have a 6-foot cord. Is that a problem or anything that may change, Carl, or is that what we have?
Very good feedback. At this time, we have the cord that's on there, but that's not to say that down the road we won't make a change. First, I know that Grundfos has the longer cord, but that's the first I've had of feedback that they'd like to see the longer cord.
You have the longer cord. We got the better valve, baby, which is more important. What about deadheading for longer than 15 minutes? Realistically, how long can we deadhead without it being an issue? And our testing has shown what?
Well, I mean, we do our UL testing. We have to do locked rotor tests, and we have to run the pump in locked rotor for hours on end. It's just not an issue.
Yeah. If you've ever seen those tests, we do have to lock the rotor, which is essentially deadheading. And they run long time. Jameis asked, what is the fixed temperature setting of the disc before it closes?
Very
good question.
It's roughly around 108 degrees. Could give or take a few degrees on either side of that, but the closing temperature is somewhere in the neighborhood of 108 degrees Fahrenheit.
Very good. And that compares, how does that compare to, say, the Grundfos one?
Grundfos is, there's a closing temperature. I think their literature and our testing proved that it was about 103 degrees.
103.
Give or take a couple degrees.
And that is if it closes?
That's if it closes, yes. Their valve never fully closes, but what would be considered their closed position would be somewhere around that 103 degree F temperature.
And another question from Bernardo, what does universal mean? I have been asked this question. Can you use it on other pumps? I presume you're using I'm presuming you mean the valve itself, the hot link valve. Can it be used on other pumps?
Yeah, that's probably his question. One of the things we're prepared for is we think that we're going to sell a lot of these valves as standalone. We do sell what is an HLV-1 is the model number, and that's the valve itself. But you could take that valve and put it in place of a comfort system valve using the comfort system pump because the flow and head is very similar on that pump to the 006. So yes, good in many instances. Take a hot link valve and put it in place of a comfort valve. One thing to note is that our connection sizes on the hot link valve for the inlets and outlets are the same size as the Grundfos Comfort. I don't know how that happened, but it happened.
Almost like we planned it that way.
Almost.
Yeah. You want to, if you got a wholesaler that's that's kind of tired of replacing comfort valves with other comfort valves, that to me is an opportunity, gang, where you can sell not only just the hot link system but also the valves as replacements for the Grundfos hot link or the Grundfos crossover valves that they're constantly going through. Once you get those replacement valves into customers' hands and they see how easy it is and they see that they don't have to go back and replace it again in 9 months to a year, you're going to start to see people opening their eyes to the whole TACO solution and that we do have a better idea. So that's kind of the key. That's another business avenue that should be exploited, in my opinion, that you guys should do that. Alrighty, well that's our stuff. Let's go over the competitions kind of quick in the different categories, okay? Let's talk about what the competition has. Let's start with your basic plumb and plug competition. What's going head-to-head to our basic plumb and plug? The most common one is the Grundfos 1016, UP 1016, which Carl yesterday said called the Razor because it looks like what, a Norelco?
The shaver pump. Looks like a Norelco.
Yeah, it's a little shaver pump. There you go. It's a cute little pump. It's got a line cord and everything, and they have different models with different features. The highest end model is the ATLC model, the ATLC. The LC stands for line cord, T stands for timer, A stands for Aquastat. So they all don't have it. You may have just the TLC, which has the timer and line cord. An upgrade is the Aquastat timer line cord, the ATLC. That's kind of their high end, where everything's all built in, okay? Everything's all built in. They also tout in their literature, because this is Grundfos we're talking about, they tout in their literature that it has a built-in check valve and an built-in isolation valve. But if you look at everything closely, it's only the 1.25" model that has that, okay? It's push button or push little dippy switch programming, and each little dippy switch is worth 20 minutes as opposed to ours, which is 15. And it's a small pump, 3.5 GPM, 5 feet ahead max. It's basically a 003 more or less. Okay, real similar to your basic plumb and plug in that application. Okay. Now, another player in this whole house recirc, and something that is comparable to it plays in the same sandbox as the Smart Plus, is the Grundfos Comfort PM. Now we're looking for pricing and stuff on this, gang. I can't seem to find them anywhere online, and I really haven't seen too many out in the field. We have a few of them at the office that we were able to get our hands on, but this is kind of Grundfos's new latest and greatest. It's a UP1016 pump, but it's an ECM circulator, so it's a high-efficiency motor with built-in auto-adapt. It's their version of domestic hot water auto-adapt, which we'll discuss in a moment. It's a 2 GPM, 4 foot ahead max pump. It's a little pump, but again, for what it needs to do, that's all it needs to be. It requires, because it's Smart Plus-like, it does require a strap-on sensor. And this strap-on sensor, if you take a look at that little black ribbon coming out of the end of the motor, that's your sensor. It's integral. The strap-on sensor actually comes out of the box connected to the pump, and really what it does is it acts as kind of like almost a tape measure kind of thing. You've got to pull it out of that housing up to 36 inches to strap onto your hot water pipe. So it's kind of like a tape measure almost. And Carl kind of had some experience with that yesterday, and he'll chime in on that in a moment. Now, like the Smart Plus, this product learns your use patterns. It has a 2-week learning period. It learns your use patterns and then kind of mirrors those patterns in how it operates. So the Auto-Adapt Smart Plus, kind of similar in that respect, but there are some there's some functional differences that you need to know about that'll make, I think, give the Smart Plus some advantages, even though it's not ECM. Let's take a look. There are 3 modes of operation. I'm sorry, if we go back right here, you see these 3 modes of operation. You got this little thermometer thing, which indicates it runs on temperature. You got Auto Adapt, which is like Smart Plus, learning mode. And then you got 100%, which obviously means it runs 100% all the time. If we take a look at the details, in that temperature mode, it simply runs like, it has an aquastat, which works as a high limit. Meaning the pump will run all the time unless the aquastat says, you know what, you're good, stop. All right, and it has a fixed temperature inside. I'm not entirely sure what it is. I would guess it's probably in that 110 mode or whatever. It just shuts the pump off when the temperature reaches that temperature. Otherwise, it runs all the time, shuts off on temperature. Runs all the time, shuts off on temperature. The other mode is the 100% mode, and that means it runs full speed, full time. It's full tilt, full time. All right, so if you put it in one of those 3 modes. There is no pulse mode like we have with the Smart Plus, which I think is an advantage for the Smart Plus, because now it doesn't have to run all the time until the temperature tells it to turn off. It doesn't run all the time, full tilt, full time. It'll only run 2.5 minutes on, 10 minutes off, 2.5 minutes on, 10 minutes off for those irregular use patterns. So I think that's a bit, in terms of benefits, I think that's a big difference. That is a big difference. The other difference is that with ours, the holiday mode, we jump into it after 36 hours. With theirs, they jump into it after 24 hours. So that would be a difference. And this circulator is also available without the auto-adapt function. So it's a more basic version. Now, Carl, what can you tell us more about this particular pump, specifically your trials and tribulations with the sensor?
Well, a couple of things. First, just to talk about the pump itself, you notice in your last slide that it's a very low flow, low head pump. So it's going to struggle in those larger homes to satisfy the hot water demands. Our Smart Plus, we have a 003, 006, and 008, so we can pump more water to higher resistance to satisfy those larger homes. So that's one other big advantage, I think, between the Smart Plus and the Comfort PM. But in regards to the strap-on sensor, it's very interesting. You take the pump out of the box and you grab the end of the sensor, and you have to, if you look at this picture that John just put up on the left, where you see Grundfos in black, you have to rotate that head counterclockwise as you hold the strap. You see the burgundy or red lead on it. You have to hold that as you rotate that cap counterclockwise, and it will release the sensor, which is about 3 feet long. It looks like a piece of tape, really, kind of a semi-rigid piece of tape that looks like it would be really difficult to meander it around some piping if you need to strap it on. Also, because it's only 30 inches long, it's going to be difficult to strap that on a pipe if where you install the pump in relation to where that sensor has to be strapped is more than 3 feet. You really can't extend that sensor. So I'm not sure at this point until we do more investigation on the pumps we have where exactly that sensor has to be on and installed. I'm assuming it has to be on the hot water supply pipe. So that may be the following. Again, if you have a distance greater than the 30 or 36 inches, that will extend. And the Smart Plus, we have a sensor wire that you can splice in additional wire if need be. Doorbell gauge wire, just splice it in, extend the length of the Smart Plus sensor to whatever you need for time. If you install the Smart Plus on a return, you could increase the length of that sensor up to 10, 12 feet if need be to get it in the right spot on the supply pipe.
And so again, we have an awful lot of options, and you cannot just pull that sensor out. Like a tape measure, you do have to rotate the head.
Yes.
Okay, very good, very good. Just go back on some Hotlink information. Dave Houston, from our friends down at BJ Taroni, had a couple of points. He says he had a Grundfos comfort system for years and always had hot water in the cold line when the valve worked at all. Enough hot water I had to run to get cold, so he had to run some hot water out of the cold water line to get cold water. Now, let's continue this here. It's kind of killed the savings. Installed a Hotlink. Both the valve and pump fit right where the Grundfos was, and it worked fantastic. So here's a testimonial from our friend. Barely any tepid water in the cold line at all. So there is a testimonial from one of our own, Mr. Dave Houston. Thank you, Dave. All righty. Some more whole house options. This is the B&G EcoCirc E3 series. You may see those out there. Very simple, limited pump. It just does what it does. It's an ECM circulator. Again, Vario, meaning you can dial in the speed that you want. I'm not entirely sure why you might do that, but you can. Or it can work on a fixed speed. 24-hour timer, 30-minute increments with the little dippy switchies. And then there is an optional pump, an upgraded pump, that gives you an optional thermostat option, a T-stat option, or an aquastat option to help turn the pump off. But what this one does, it has an adjustable set point. You can actually set the temperature for the water temperature that you want, all right, 68 to 158 degrees, and that's your high limit, and it'll enable the pump when the temperature drops below that 10-degree set point. So this is it's going to have a high limit and a low limit. This is the kind of pump I think that would be aimed at the I don't give a darn how much it costs, I always want hot water people. All right? So I'm always going to have hot water. It's always going to run, unless we're at high limit, or it'll always run in that time frame. Okay? You can set it up as a timer, and you can set it up as a thermostat option, or both if you wish. All right. Now let's take a look at the crossover valve competition. Again, here's the kind of the target, the Grundfos Comfort System. It's a UP1510 pump. Very similar to a 003, maybe just a little skosh above, but that's about it. Analog timer, 15-minute increments on this, and then you have the quote-unquote industry standard, non-serviceable, in reality, crossover valve. In theory, you could service it. In reality, once you take one apart, you probably wouldn't bother. And industry standards in quotes, because it's actually setting a fairly low standard for that type of product. Again, when you start to look at what we can do with ours and what people have experience with theirs, you start to see a really huge difference. We're going to talk a little bit more about that crossover valve in a minute, but this is the comfort system in a nutshell, and this is another under-sink bypass crossover valve type of system, the B&G Echo Wireless. Again, you have a circulator ECM 24-hour ECM circulator with a 24-hour timer. All right, and there's and then the under sink crossover valve is actually battery operated, and what you have is radio frequency communication. They kind of communicate to each other wirelessly. Right, so it's like a garage door opener, you know, or any of the wireless buttons that we have for the Genie. It's wireless communication. So you have an onboard temperature sensor in that crossover valve, as well as a radio frequency transceiver. You have 2 AA batteries in that valve, which again, there's a service item just sitting there waiting for you. So you have 2 AA batteries in the valve. You set the temperature you want the valve to react at the pump. Okay, so you set it at the pump. The valve kind of picks up on that. Okay, and then it operates based on your time, your timer, and the temperature feedback from the crossover valve. You can also get an optional radio frequency push button to also enable the pump if need be. Okay, otherwise it'll run on timer / temperature, and if you're in a situation where you want it to run when it's not supposed to be running, you can turn it on if you need to. Okay, so again, kind of a neat, slick, high-tech solution, but let's take a closer look at it. Now, the Grundfos, some thoughts on the Grundfos. If you take a look, I love that picture. I had to search far and wide for that picture, but as you can see, the timer and everything on the left-hand side of that pump melted off somehow, some way. I'm guessing there was some sort of an electrical fault inside, and it just kind of melted, which is kind of funny. But anyway, you still have to set your timer dip switches like you have to with the Hotlink. But it's the crossover valve that's the weak link. It really is kind of a weak valve, and the whole pump itself is kind of bulky compared to the Hotlink valve, which has the timer right on the end. It's a little sleek, takes up a little bit less room, which is an advantage. But Carl, can you talk about what's involved with servicing? First off, how does the Grundfos crossover valve work? How is it different from ours? And what if you were to service that valve, what would you find? Let's talk about how it works first.
Yeah, the Grundfos valve works similar to ACO's 571 terahertz, where it uses a clarifying wax and a piston. So as the warm water reaches that and starts to heat up the clarifying wax, the wax expands, pushing a piston into an orifice that, as the piston moves through that orifice, it restricts, it continually restricts flow, to where it gets down to very little flow from the hot side to the cold side. The valve itself can handle about 1/4 gallon a minute through it. It's very slowly acting. When it's heating up, it's time to heat it up to get it to the closed position, and it takes time for it to cool down and open up again. So when someone spoke earlier, or someone sent in information saying that when they had the Grundfos valve in, they had a lot of warm in their cold versus the Taco Hotlink, that's the reason. It's a slowly acting valve, and when it becomes stopped up, and it'll get stuck in whatever position it is at the time when it finally sticks. It's usually the open position, so it's just as long as the pump is running, it's allowing that warm water to move into the cold line. And as it gets older, it wears and sticks a little more. You get more and more warm into the cold line. To disassemble it, you have to remove the valve from the piping. So you have to shut your water off, take the entire valve out, and then you've got to take it apart. It's a complete disassembly. So you have to disassemble it, and then put it all back together and put it back in. And most of the guys I've talked to who work with them, they'll just throw them away and put a new one in. And the Taco Hotlink valve uses the disc technology, which is a very fast reacting element inside, or thermal disc inside the cartridge that is removable and cleanable. So when the hot is up there around that temperature of 108 degrees, the thermal disc immediately starts to the closed position, and it's a positive shutoff. You don't get any water passing from the cold, from the warm to the cold side when that disc is in the closed position. When it cools down to temperature to open, it snaps open, quickly. So you get that flow back and forth, and a very fast reacting valve. And again, you can easily service the valve. The features of the Hotlink valve is that clean place design. So you shut off the feed water to the valve and on the hot and cold side, and then you simply unscrew that cartridge, take it out, clean it up, put it right back in, screw it back in, turn the feeds back on, and you're up and running. So it usually doesn't take more than about 15 or 20 minutes to clean out the Taco hot link valve.
Very good. A lot of differences there that make a difference. The B&G, again, the question you have to ask is, this thing has 2 AA batteries underneath the sink. A, how often do I got to replace them? They claim that it's good for 2 years. And B, how easy are they to replace? You still got to get under the sink and replace the batteries. If anybody has ever lived with a chirping smoke detector, okay, you understand about batteries and changing them. You say, yeah, I'll get to it. I got to get some. Do we have any AA's in the house? No, I don't. I'll remember to go get them next time out. Oh, I didn't get any next time out. And it starts to develop those kinds of issues. Now, the pump and the valve do have to be paired. And the process that they explained, it sounded an awful lot like trying to pair something to Bluetooth, which is a little cumbersome. But I got to believe it's not all that different from maybe our RF buttons for the Genie. But it does. There seem to be an awful lot of steps involved. So just to understand that can be an issue out there. Your remote button could be either an RF button for enabling, or it could also be used instead as a signal repeater. If the valve itself is more than 150 feet away from the pump, the little RF button could be used instead as a signal repeater to make up for that distance. In either case, the button as a button or a signal repeater, it has to be plugged into a wall outlet in order for it to do anything. So it does take up a wall outlet somewhere in your living space. They're not unattractive, but they're there. Here's the other thing too. It does not come equipped with flex hoses. None of the B&Gs do, which I found interesting. There are no flex hoses in the box. It's something you have to buy as well. It's not included. It is an extra cost. So just something to think about.
And John, if I could add something to the Xylem B&G, if you go back to that slide, one other real negative. This is a very clever design using the battery-operated valve under the sink that speaks to the pump. It's very clever, but they're still using down at the hot water source. So your Saturday and Sunday habits need to be the same as your Monday through Friday, or you have to set the program and the timing on the pump for a very large window of time to operate, or you have to use the manual push button starter. And it's a small pump, low flow, low head, and I'm sure there's a lot of restriction through that valve and through the piping system. So to get that water quickly by the press of a button is probably not going to be so quick. It may take a considerable amount of time versus using a Taco Genie, which is a high head, high volume pump that's going to get the water there quickly, and you're going to have it when you want it.
Right. Again, interesting idea. As you said, interesting idea, but the execution has some holes in it. I mean, it's a cool idea, but as you said, if anytime you got a 24-hour timer, it's going to do the same thing every day, whether you need it to or not, which is, I think, a weakness of any 24-hour timer. But in addition, again, if you do want to use the push button, say you have it set for run between 7 and 8 a.m., and on Sundays you don't get up till 9 or 10, all right? You want to get up and take a shower, you got to remember to push the button if you have the push button. And it may take, as you said, it may take a while for that water to get there because it's not evacuating the line quickly. So in a timer, you don't have to evacuate the line quickly. But if you're in a hurry, if you want it to run when you want it to run on a weekend or when the pump isn't running, it's going to take a while. So again, there's trade-offs for everything. Which again, very good point, Carl. Bravo. Another undersink competitor is the AutoCirc from B&G. And as you can see, this is a circulator with a crossover valve kind of built in that goes right underneath the sink. Again, low flow, low head pump, an ECM pump with a 24-hour timer. And they have models with either a fixed temperature or an adjustable temperature. So it'll turn on and off, or turn on rather, at a specific low limit type of temperature. Okay. And again, here's what it looks like underneath the sink, but again, hoses not included. So again, you got to buy other stuff to make sure this thing works. And here's something I found that was very interesting. You got that 24-hour timer, but if you want to go on vacation mode, you actually have to physically reach under the sink and shut the pump off. It actually has to physically be turned off for a vacation mode, which again, it's an interesting thing that they put in their literature. And then for the demand pump, this is the ACT demand system, which is similar to the Taco Genie. And this the demand name should sound familiar if you've been around. It is a Grundfos pump with a demand type control external to the pump. As you can see, the circulator, if you look at the circulator here, it's a Grundfos pump, and there's this line cord that connects to the control box that it has to be plugged in. This plug is like the plug that you would use to plug in, say, a computer monitor or something, that actually physically plugs into the control box itself. You have to physically do that upon installation. They offer 3 separate circulators as options. The smallest pump is a union connection, as you see here. The 2 other pumps are flange connections. And what they tell you in the instructions is you have to assemble the flanges. You have to assemble the flanges ahead of time before you move the pump underneath the sink. So it's really a cumbersome installation. The control itself is external, and there's a heck of a lot of under-sink wiring that needs to be done during this installation, as opposed to the Genie, where it's just one compact unit. The wiring, this is what you get when you take it out. You've got the control box. You could have either mounting eyelets, as you see there, or just a strap of Velcro on the back where you Velcro it to the wall of the vanity, which is seriously high-tech. You have the power cord coming out of that box, but also a bunch of wires coming out of the other side, a couple gray wires and a black wire that connect to different things. All right, you've got a wire for your manual push button that you have that's in that package. You have a wire for an RF receiver if you're going to use a radio frequency push button, a wireless push button. So there's a wire for the hardwired activation. There's a wire for the wireless activation receiver, and then there's a wire with a little Molex plug on it to plug into the sensor, the temperature sensor in the pump itself. So all those 3 things have to be wired up. Have to be wired up onto the sink, and those wires are kind of sitting there. So it just makes it a little bit different and a little bit cumbersome. And in addition, there's no real mounting. There's nothing integral to the circulator for mounting it onto the sink. As you can see from this picture, which is taken from their website and from their instructions, the control box is mounted on the wall. The pump's sitting on the base, is just sitting loose on the floor of the vanity, which I'm not sure that's a good idea in any situation. They may have a separate mounting bracket that you can purchase, but again, with the Genie, that's kind of that mounting bracket's kind of built into the circulator itself. I looked at this; it took me about 5 minutes to figure out what was wrong with that, and just freaking pump sitting on the floor of the vanity, just loose essentially. And I'm not sure, again, that's really what we're after. Up in that picture in the upper left-hand corner, there's your wiring connections for the RF enabler. Again, it's got to be hardwired under the sink. So there's just a lot going on here with this particular pump. Now, Carl fed me these pictures yesterday. That's Rick Brindamore's iPhone. And now you get a comparative analysis of both the size of the circulator, of course, and the size of the control box as well. So you've got to have room for both of those things under your sink. All right, it takes up some space there, and it's, again, very cumbersome. And you don't have a long connective wire between the pump and the control itself, so you got to be concerned a little bit about that. Okay, and here's a different view, a little wider view, and there you see all the wires connected to the box that you have to uncoil and install. And to me, this seems more do-it-yourself, or the instructions really seem focused at a do-it-yourselfer more than a professional. Because I got to believe a professional is going to look at that and say, I'm putting in the Genie. Why screw with this? But you could see a tinkerer, a guy, one of those California handymen who would just get off on this because they seem like they're doing a lot of steps to do something good, where another option would be a heck of a lot easier. But again, if you look them up online and you read the installation instructions, they really do seem as though they are it's targeted towards a do-it-yourselfer. And no offense to the California handyman, Zachary. No offense intended. Okay. Now, are those connections plastic? Carl, you had that in your hands. What about the connections to the water? What is that? What's that connection like?
Yeah, on this particular model, I believe they're called their C3 model. They're plastic connections, and have heard that they've had some issues with overzealous plumbers over-tightening and cracking the volutes on the casings. So,
Plumbers overzealous with tightening? I'm shocked, I tell you.
you believe that?
Well, I have a plumbing license. I'm here on the wall. I can tell you, yes, we are overzealous. If tight is good, tighter's better, man. Now,
John, is that a granola bar on the back of that box, or is that the peel and stick to mount that on the wall?
that looks like it's the peel and stick right there, the Velcro. There you go. The connections, Bernardo, for the larger models are stainless steel flanges. Okay, and I think if we go back, let's go back here. Oops, sorry. Let's go back a few. Yeah, this picture right here, you can see the stainless steel flanges here. Okay, so again, the larger pumps are flanged. The smallest pump is those plastic union type connections.
And just for the folks in Rio Linda, on the flange version, if you go back to that picture, the IFC is actually in the flange side of that pump, so it's not in the volute of the pump. It's in the flange, and you do a pre-assembly of all of that before you put it under the sink and then wire it into all the other contraptions.
Very good, very good. A couple more questions here. Bernardo says they could leak on new construction. Sure. How many people really have a power outlet under the sinks? Not many. You know, that's always a concern with whether it's the Genie or this. Either a power outlet under the sink, yeah, you know. Sometimes that needs to be clipped and hardwired. I mean, I hear you. It's not a common thing. Okay. Now let's take a look at the tail of the tape. Just some feature benefits charts comparing our stuff to the main competition. Start with your basic plumb and plug and its contemporaries. You know, for motor, you got standard efficiency with ours and the Grundfos. The B&G EcoCirc is ECM. Timer, we are analog with a digital option. The other two are both analog, 24-hour, that's it. Temperature control, it's optional with a remote aquastat, but it's the same pump. It's just whether you buy the aquastat or not. Now, with the Grundfos and the B&G, temperature control is optional, but you need to buy a different pump. That's kind of an important difference. Same pump with whether you want temperature control or not. With the Taco, you just have to buy the aquastat. With the Grundfos or the EcoCirc, you have to buy a different product, a completely different product that has the internal sensor built in. Programming tabs, I'll use little tabs or dippy switchies. 15 minutes for us, 20 minutes for Grundfos, 30-minute increments for the B&G. And we have digital programming, 7-day, 8-event, 56 total. The other two do not have digital programming, optional. And we have the two models, the 003 and the 006. The Grundfos 1016, it's just the one. And there are two models for the B&G EcoCirc, the E3-4 and E3-6, and very, very, very similar performance to both the 003 and 006 there. Crossover retrofit options. We have the Hotlink, the Comfort System, and the Eco Wireless. Again, motors, standard for us and Grundfos. B&G, all in on the ECM with Eco Wireless. Timer, we have analog or digital. Both of those other two have analog only. Our crossover valve is truly serviceable. The Comfort System, very well known. It is a throwaway valve. And the Eco Wireless is battery operated and really unknown if it's serviceable or not. I don't know if any of you guys have seen those anywhere. If you have, you know, let us know what you have found. Distance limits, none and none for us in the Grundfos, 150 feet max with the Eco Wireless unless you get the repeater. Both the Hotlink and Grundfos include hoses. ECM does not. The Eco Wireless does not. We have two models of pump available for the Hotlink, the 03 and the 06. Comfort System, just the one pump. Eco Wireless, just the one pump. And there's no... Yes, sir.
Correction there, I'm sorry.
Yes, sir.
On the Hotlink, we only have the 006 model available.
Oh, pardon me? Just the one, 006? My bad. I'll take that out. Thank you for sharing that. I'll make sure that's corrected in the final version. Valve setup, none and none for us. Eco Wireless, you do have the RF pairing and the plug-in signal repeater if necessary. So there's a little bit more to it than just setting it up, just sticking it in and letting it go. Okay. For Grundfos, whatever material, what type of material do they use to cross over water? please send crossover sheet. Let me know, but I'm not quite sure. I'm not following you on those two, Bernardo. If you could restate, so I understand what you're saying. These comparative sheets, they will be. What we're going to do is we're going to we'll be archiving this presentation as a PDF for your internal use only. Okay, internal use. These types of differences are going to be good references for you to learn about the differences between our product and theirs, so you can, when you go out in front of your customers, you can actually speak to them intelligently of the differences. What I don't want is this to be copied and handed off to a customer. That's just kind of cheating. Learn the stuff yourself and be able to tell them the differences. Okay, that's the importance of these. So we know the differences in these products. And lastly, the under-sink demand types. Again, the reason we don't want this out is, these are a little glib. These are for us. These aren't for please do not give these out to customers. These are for you to learn, and so you have that information in your heads and when you are presenting. Again, features here for the Genie, the Demand, and the B&G AutoCirc. Again, standard and standard motors for us, and for the Demand. B&G, as we said, all in on ECM. Everything they have there is ECM. Control for us is on demand. Control for demand is, of course, on demand. B&G is timer aquistat. So there's a weakness there. B&G is timer aquistat, not going to be applicable at all with your tankless. All right. Hoses included, yes and yes for us in the Demand, no for the B&G. Models available. You see 3 of ours, 3 on demand, just the 1 for the AutoCirc. And ease of installation with the Genie, it's really easy. With the AutoCirc, it's really easy. With the Demand, again, you just look at it, you got to be kidding me, right? Okay, that's as a guy who used to actually work for a living under sinks, and I'm sure a lot of you guys out there also work for a living under sinks. You're looking at that and you're thinking, okay, you got to be kidding me, right? This can't be true. You can't be serious. And that is that. That is our presentation here, gang. Lots and lots of great questions today. Really do appreciate it. And now is the time for you to continue asking whatever questions you would like of both Carl and I. We had 37 of you here hanging out through the whole thing, and that's pretty awesome. We really do appreciate that that gift of your time. But now's the time to chime in with questions, thoughts, ideas, marketing ideas. Where are you gonna? How are you going to approach your customers? Just fire away, gang, and let's see what you have. Anytime now. Okay, James, thank you from James. Very good. Thank you, James. And yeah, keep those questions coming in. There must be some, because we left out a lot of the good stuff. Where are we with getting the hot link back on the shelf, asked Adam Christensen. Where are we with the hot link, Carl?
We are shipping. So any returns that we had to correct an issue with the screens in the valve bodies, we have made the correction, put them back in. They are shipping out from now.
Okay, so send in your orders. They're on their way out the door. Excellent. Very good. Very good. Good question. Let's see. I'll use my own. Let's see. Curtis Wondrous says, "I'll use my own situation for a question." Okay, looks like he's in the process of typing that question in for his own situation. I'll give you. While he's doing that, I'll give you my own situation. This thing right behind me, if you can see on the webcam, that is my that's my boiler. It has an air handler built in for forced air upstairs. We have hot water heat downstairs, radiant floor panel radiators. But also built into this is it's a boiler with a heat exchanger, an external heat exchanger that makes my domestic hot water. There's no storage. So it's basically a tankless type water heater or an instantaneous type water heater. For this application, the Genie is the appropriate approach. What we will do is we'll put a Genie down here, and I'm going to run a PEX line from my master bath way over here. I'm going to run a PEX line from the master bath or from the main bath. I'm not sure which one's going to be easier. I use the main bath, the wife uses the master, so I'll probably just do it for mine because that's the way it is. But in the summertime and spring and fall, when we're not running the boiler a lot, we do have to wait a few minutes for the boiler to heat up and the water to get hot. So a Genie with either a push button or a motion sensor would make that happen like that. So we'd be able to start the thing up, get it up and running. It'd take a couple of minutes to get the boiler up. The boiler has to get up to temperature to make the hot water, and then we're creating that flow and evacuating the hot water line. We're creating the flow for the water tank, get the water temperature up to where we want it to be, and then we're ready to take a shower. So right now, if I were to turn the shower on, it's probably a 3 or 4 minute wait for hot water, maybe a little longer. In the middle of winter, when the boiler's running anyway, bam, it's not that long at all. But in the spring, summer, fall, it does take a little bit longer. So that's kind of the approach that we would take here. The long and short of that story is, when you're dealing with lay people, like end users, homeowners, and even some tradespeople, I had this conversation at least four or five times in the past week. When we're talking about domestic hot water recirculation, well, what if I just have one of those tankless instantaneous water heaters? Won't that solve the problem? Not getting that makes hot water immediately at the hot water tank. We still got to get it to the fixture. Okay, there still has to be something to get it from here to there. The only thing the tankless takes out of the equation is storage. It doesn't instantly deliver hot water at the fixture, and so many people ask that question. So that's a great story for you to develop, to share with whether you talk to homeowners about whatever situation, or whether you're talking to contractors to help them answer that question. Because people still think that people don't get the whole idea of domestic hot water recirculation. The average homeowner doesn't quite get it. What is it, a booster pump? It's supposed to boost the pressure, make the water come out faster? No, it's just to get hot water to your fixture. Very difficult concept for your average homeowner to really get his arms around. So again, something for you to think about when you're developing that, and understand that your customers need to know, so they can explain to their customers that this is a question their customers are going to ask. So, a tankless water heater, instantaneous water heater, means it makes hot water at that tank. You still got to get it to the faucet, and that's where recirc comes in. One without the other doesn't, it doesn't help you get hot water faster. It just makes water. It just takes the storage out of the equation, which has efficiency benefits, no doubt, but it doesn't get hot water to the fixture faster. All right. Now that little stump is over, let's see if Curtis finished this question. Here we go. Master bath where the pump will be. I want motion sensors there and in the kitchen. I'll need the pump, 2 sensors, and a transmitter receiver kit. If it's just motion sensors, Curtis, I would think you don't need the transmitter receiver kit. Transmitter receiver kit's just for the remote push button. The sensors are hardwired, so you would have to hardwire those. Does that would that be accurate, Carl?
Well, he may want both options. He may want to use a motion sensor in a couple of areas and then a remote push button in another area, or multiple push buttons in another area to start the pump, which is certainly doable.
Okay, so yeah, you can put motion sensors. Motion sensors are hardwired, but the transmitter receiver kit is just for that push button. So if you want to put a push button somewhere, that would work. Michael Durr asks, will this be reviewed again at the Nashville sales meeting next week? Yes, it will be. Yes, it will be. All right, very good. Thank you, Gene, for your comment. What material does Grundfos use in their crossover tee? As Carl said, it is a paraffin wax. It is a paraffin wax element inside that crossover tee, so it is very slow responding, as Carl mentioned earlier. And what happens when that fails, Carl? Did we go over that? What happens when that crossover valve fails? It usually fails in the open position, correct?
Well, it could fail really in any position. It seems a lot of times it will fail in that open position and get stuck in the open position, and then you'll hear complaints from customers that they're getting that really excess hot water in the cold side, and some people have even reported that they see steam coming off the toilet with the seat up. So that's kind of the common failure there, and fun little story, I guess.
Yeah. Yeah, so it is paraffin wax in, and that's what happens when it fails. And now you get that story, oh, I don't want to use something under the sink. I'm going to get hot water out of my cold water. I have a buddy that did. Well, that's why. Okay, that's why. So again, we've got such a much better mousetrap here that we can present to our customers. But don't ever fall into the trap, into the abyss where you start thinking, well, if I have a better mousetrap, everyone's going to know about it. Ralph Waldo Emerson said, build a better mousetrap and the world will beat a path to your door, and that's a load of hooey. Ralph Waldo Emerson's a frickin' moron. He never sold a thing in his life. He doesn't know what he's talking about. You do have a better mousetrap, but you do got to sell it to people and make sure they understand the differences and understand why it's a better product and will be to their benefit. And that's you selling your product to those people. Just because we know it's a better mousetrap doesn't necessarily mean the wholesaler knows or cares that it's a better mousetrap, nor does it mean that the contractor knows or cares that it's a better mousetrap. But of the two, if it is a better mousetrap, I guarantee you that the contractor's going to want to know about it, and that story is going to matter to him because he's the guy that's got to live with the aggravation. So just make sure that that story does get told. It reminds me of my favorite poem. Well, one of my favorite poems. And one of my three favorite poems, one I can't reply. One's a limerick that just stays here. The other is a long epic. This one is just a quick poem that I can share with you that applies to this situation. And it goes as follows. He who has a thing to sell and goes and whispers in a well is not as apt to get the dollars as he who climbs a tree and hollers. Like that one? Like that one, Carl?
That was deep, John.
Yeah, it is very deep. You didn't know I was into poetry, did you? I
had no idea.
I had no idea. Sometimes I walk through fields of spring flowers with a book of poetry, reciting it out loud to no one but myself.
Are you barefoot at the time?
Sometimes. Sometimes I'm barefooted, yes. All right, a couple more questions from Dave Houston. When the Grundfos crossover valve fails, you get scalding hot water at the cold tap because Dave knows from experience. Yes, you certainly can, and that's kind of an eye opener, isn't it? Yeah, so they've done more to hurt the domestic hot water recirc industry, I think, than anything else, just with that one particular problem. So good. Keep those questions coming in, guys. We'll stay on as long as you want. As soon as the questions dry up, Carl and I are going to go have lunch together separately.
I had lunch before this, but
thank you.
I may have to go have a snack after.
Oh, well, there you go. I'll have some lunch afterwards because right now it's almost 1 o'clock, and the mail comes at 1 o'clock, which is always good.
Yeah, release the dogs.
Release the dogs. They've been quiet for a while. They have a way. They just seem to know when all is quiet. One yaps, and we actually have a visitor dog today. Dog sitting for a friend of the family, and she brought her dog over too because she's away at work all day, and she doesn't want her dog alone. So her dogs come and hang out with our dogs, and then we have a band of 3, which is nice. And not a one of them weighs over 15 pounds. So 3 little yippy dogs. When one barks, they all bark, and it's like, especially when I'm trying to take my afternoon nap. It really does get to me, Carl. I don't know.
That must get in the way of it.
It does get in the way of the afternoon nap. Well, all right, gang, it seems as though the questions have dried up. If you do, in fact, have no more questions, I will thank you for your time. We do appreciate you